Hey guys, have your notes here for section 9.2. We're going to look at hyperbolas today. They might be a little more confusing than ellipses, but they have a lot of similarities, which will be good. You don't have to memorize a bunch of new stuff. So let's just take a look at these. Remember, hyperbolas are basically two parabolas opening away from each other. They can either open away from each other horizontally, or they can open away from each other vertically. You're going to need to be able to look at the equation of hyperbola. Notice that they always have a minus sign and they always equal 1. You need to be able to look at the equation of a hyperbola and quickly determine which way it opens. Okay? Now here's how you're going to do that. And remember, in an ellipse, I told you, in an ellipse, you look for the larger of the two denominators, and that tells you which way it opens. Not in a hyperbola. In a hyperbola, you're going to look at the positive of the two denominators. So this one's positive. How do I know? Because there's nothing out in front. This one's positive, thus the hyperbola is going to open this way. Over here. This one's positive. Look what it's under. This one's the positive one. It's going to open this way. Lock that in your brain. You need to remember that. Now, here are the parts to a hyperbola. We still have a center. And that's still going to come from H and K. Still have a center. We still have our main vertices along our major axis. So we still have our major vertices, and the good news, the distance from the center to a major vertex is still A, just like it was in an ellipse. B is always the distance in the other direction. So this is A, this is B. When you know B, you can make this point up here and this point down here, and they look like they have nothing to do with the hyperbola at all. They look like they're just out there for no reason, but there is a reason. We're going to put them out there. So we're going to figure out what A is, we're going to make our vertices. We're going to figure out what B is, we're going to plot those points. We're going to take all 4 points that we've plotted, these two, and these two, and we're going to make a rectangle out of them. Kind of lightly, but we're going to make a rectangle out of them. Remember, I said this is A, this length is B, okay? And the reason we want to make that rectangle is because we need to draw asymptotes that hold in our hyperbola. The asymptotes are going to hold in each branch. Each parabola is called a branch. They're going to hold in each branch of our hyperbola. The asymptotes are. So to draw the asymptotes, you figure out A, you figure out B, you plot them, you draw your rectangle. Ready? Asymptotes are going to be a line that passes through the center, and through each corner of my rectangle. They're going to be light. They're asymptotes. We don't want to make them too dark. Through each corner, I kind of missed on those, but whatever. Through each corner, of my rectangle. That's why this A distance is so important and this B distance is very important. And the distance from the center to a focus is still C. Right? The distance from the center to a focus is still C, just like it was in an ellipse. The thing is, though, a focus in a hyperbola, each parabola is going to wrap around the focus. each branch, each parabola is going to wrap around. It's going to focus on the focus. It's going to focus on the focus. So remember, in an ellipse, our foci were within our vertices. Well, not on a hyperbola. A hyperbola, the foci are out here, out beyond the vertices, because our parabola has to wrap around them. So, the good news was this distance is still C, from the center to a focus. And now A, B, and C have a special relationship, but it's different in a hyperbola than it is in an ellipse. Here's the ABC relationship for a hyperbola, and it's this. Again, given to you. You don't have to memorize it. All this other stuff, center, you need to know that, but how you determine the vertices, how you determine the foci, transverse, blah, blah, blah. I don't do any of it. I don't memorize because it's all different than what it was for the ellipse. There's no way, I don't think, you can memorize all the stuff for a parabola, all the stuff for an ellipse, and all the stuff for a hyperbola. I want you to understand it. Draw yourself a sketch, and you'll be able to come up with any point you need. Okay. More vocabulary. Ellipse, we went major axis, minor axis. Hyperbola, they have to use new words. The transverse axis is the major one. The conjugate axis is the minor one. Why they do that to us, I'll never know. Eccentricity, there's still eccentricity of a hyperbola, and it again is C over A, so that's still good. Okay, and this is telling you, look for which one's positive. All right, let's go. Let's start doing some examples. We're going to do standard form of the equation of the hyperbola. I need one of these two pink forms. Not sure which one yet because I have no idea how this hyperbola is oriented. Let's find out. Centered at the origin. Okay. Check. Major axis length is 4. I don't know where to put it. I don't know whether to go out 2, or out 2, out 2. But this tells me the foci are at positive 3, 0, negative 3, 0. Aha. Now I know my major axis, my transverse axis, whatever. Now you can put your vertices on there. So if the length is 4, I'm going to go out 2 and out 2. A is 2. C is 3. Yes? Okay. We need B. We're going to need B to write our equation. Let's just go ahead and find it right now. So C squared equals A squared plus B squared. Sub in your numbers. 3 squared equals 2 squared plus B squared. I got radical 5. And since our hyperbola opens this way, remember I know that basically because of the location of the foci, my hyperbola opens this way, I'm going to use this one where the x is in the front because it opens this way and that's what needs to be positive. All right? So that means that the number down here has to be associated with the major axis. Center was at 0, 0. A, major axis, A was 2. B was radical 5. positive one, orientation. Next one. I went ahead and graphed some of them for you. I just went ahead and plotted the two foci, no big deal, and I plotted the two vertices, no big deal. So since the foci are along the x-axis, that tells me that it opens this way. And remember, you need to start them from your vertices. And then this also tells me, since my vertices are here, my center must be right in the middle of them. My center must be here. So 1, 2, 3, 4. My center must be at 4, 0. So what's A? A is 1. Let's see. A is 1. B, I don't know. C, oh, I can do C. C is go from the center, either direction, go to a focus. 1, 2, 3, 4. C is 4. Do your equation. I got B to be radical 15. Oh, hold up. Yep, it was going the right way. I thought I did something wrong. So the one out front is going to be the positive one, and that's going to determine our orientation. So our orientation is this way. So the X is going to come first. My center is at 4, 0. A was 1. B was radical 15. Final answer. That's the simplified version. I mean, you can put the over 1, but that's kind of silly. All right, next one. Write the equation. Here are my vertices, and it passes through this point. Now, I don't have this graphed yet, but I went ahead and put my vertices there. So I think it's pretty obvious which way this opens. So here's my center. My center is at 1, 0. And A is 2. Slight problem. I don't have B and I don't have C. So I can't really do my, this thing right now because all I have is A. So I'm going to start building my equation, and you can maybe look and see what's missing and figure out what to do from there. Now it opens this way, right? You can see where the vertices are positioned, so it opens up, down. So this time I'm going to go Y first. Okay, center is at 1, 0. Be careful. The 1 goes with the X, the 0 goes with the Y. And A is 2. And A, remember that A is part of our major axis. It's the one that needs to be positive, so it's got to be linked with the Y. Okay. So basically, I had everything filled in that I wanted to be filled in except for B. I've got nothing for B. So what we're going to do, let me simplify a little bit. Just made that a little cleaner. We've got information that we haven't used. We have this point right here. So I have a nice XY combination that should work in this equation. So I'm going to sub in an X and a Y. And if I have a value here and a value here, then I can definitely solve for B. Here I go. X was 0. So that would be 5 over 4 plus -1 squared is just 1. 1 over b squared equals 1. I'm probably going to add, it's just kidding. I'm probably going to make sure that I didn't do something stupid like change a minus to a plus randomly. So make sure you got that. Okay, now I am going to, I think I'm going to move this to the other side and I'm going to subtract 1. I want this to be positive. I want to solve for b, so I'm going to subtract 1 from each side. Can you all do 5/4 minus 1 in your head? Let's subtract 1. And move this to the other side so it becomes positive. And you can either solve this in your head, b is 2, or if you can't, then cross multiply and square root and use the algebra skills that you know so well. And I get b is 2. Whew, okay, so final answer. I'm going to write it over here. I'm going to write y squared over 4 plus, no, minus. It's minus 1. Wait, can they be equal? Can these denominators be equal? Sure they can. What's important in a hyperbola? The one that's positive. Yeah, they can be equal. All that means is if I drew the little rectangle, it would be a square. No big deal. Okay, this one's going to be a little challenging. I've gone ahead and graphed everything it gave me. I plotted my vertices. I graphed this asymptote. See it? I graphed it in blue. I'm trusting that you all can graph a line. And I graphed this asymptote. See it in purple. I'm trusting you all can graph a line. Now, here's what I see right off the bat. My center is halfway between these two red points. So, 1, 2, 3, 9. My center is at positive 6, positive 1. My center, positive 6, positive 1. Okay, what else do we need? Well, we need A and B. Ooh, we've got A. We've got A. A is 3. What's B? What's B? So A says I'm going 3 out from the center. B, I don't know how far up to go. Here's the thing. Remember how I said your asymptotes pass through the corners of the rectangle that you make? And your asymptote passes through the center. So, here's the center. See how the purple line and the blue line both pass through the center? Watch. What's the slope of the blue line? Positive 2/3, right? 1, 2, 1, 2. I I got a little crazy. 1, 2, 1, 2, 3. How far did I go up? I went up 2 over 3. So from the center, watch, I'm going to color code it for you. I'm going to go up 1, 2, and I'm going to go over 3. 1, 2, 3. Oh my gosh, do you see how? I don't know if you can see the colors. Slope of the bluish line, I went up 2 over 3. This is my A distance. This is my B distance. Same thing with the purple. The slope of the purple line is negative 2/3. Watch. Up 2, back 3. So B is 2. Here's my equation. Hold on. Yeah, it does go that way. A is 3, B is 2. Final answer. Next one. I'm trying to make this as quick as possible. This was very similar to the ellipse we did yesterday, so I just started right off the bat. Get that to 1. Divide. I divided, it reduced. This is the one that's positive, so think about which way your hyperbola is going to open. A is 3, B is 2. I found C to be radical 13. I graphed everything. No, I didn't. But I will. Opens from side to side. So I graphed the center. A is 3. 1, 2, 3. 1, 2, 3. B is 2. 1, 2, 1, 2. Here's my little rectangle. Asymptote. Asymptote. A little crooked. Hyperbola. There you go. Let's complete the square. Last one. It says get it to standard form right now. You've got all these terms. Looks like a polynomial. So I'm going to have you start by grouping together your... Oh, they're already grouped together. How nice. Group together your x's, group together your y's, move this, get it out of the way. Second thing I'm going to have you do, pull off your leading coefficients. Pull off the -9. By pull off, I mean GCF, factor it out. Pull off the 4 off of your y squared. Here's what you got. When I pull off a -9, this becomes -8. When I pull off a 4, this one becomes a 2. Leave yourself some space because we're going to complete the square. Remember, you want to get this, you want something here so this factors into the same 2 binomials so that I can write them like this. So, I think this is going to be x minus 4 and x minus 4, don't you think? X minus 4, x minus 4. What do you want this number to be? Good job. What did you just add to the left? No, you didn't add 16. You added negative, shoot, I have no idea, 144. Add it to the right, keep it legal. Next one, we want this to factor into the 2 same things. So let's see, I think I want this to be y plus 1 and y plus 1. What do you want this number to be? Plus 1. Did you just add 1 to the left side? Nope. You just added 4 to the left side. Keep it legal. So here's what it looks like. There's a, this was x minus 4, x minus 4. Y plus 1, y plus 1. And then add those 3 numbers together over there and you get 36. Now, did anybody think it was weird that we were doing a hyperbola, but we got a plus in the middle? That's because here's where my negative is. So I think what you really want to do is you want to move this term to the middle. Let's put your positive term out front. So I want to write 4 parentheses y plus 1 minus 9 equals 36. But remember, that's supposed to equal 1. Now, I'm not going to touch the quantity that's being squared, but these 2 reduce to 1 and 9. These 2 reduce to 1 and 4. Right? So this is the positive one. Our hyperbola is going to open this way, up and down. A is 3, B is 2. So I went ahead and did a lot of the identifying and all that for you. Okay, now you can see it all at once. So I wrote I wrote my center. Center is at positive 4 comma negative 1. See that? A is 3, B is 2. I went ahead and found C. And I just started graphing stuff. Like, I didn't have the vertices yet. I didn't have those yet. Hold on. I started graphing stuff. I graphed my center, 4 comma negative 1. And I walked out my A up and down. Remember, it opens up and down. So I walked out my A, 1, 2, 3, 1, 2, 3. What are those red points? I named them. I went ahead and walked out B, so I went in the other direction, B, so that we can make our little rectangle. Make the rectangle so I can draw my asymptotes. Now, this is going to be a little bit of a challenge. Where are you going to put this? The square root of 13 is approximately, oh gosh, I don't know, 9, 16, 3 point something. 3 point, I don't know, 4. So from the center, go out toward each vertex about 3.4. That's what they look like. Right? So that's what your hyperbola should look like. Now, the problem is going to be coming, how do you identify what this point was? It's really yucky. Well, keep in mind, the distance from here, what was this y value? This y value was negative 1. What is it from here to the orange? Radical 13. So this orange point is negative 1 plus radical 13. Okay, hang on. I need the x value first. The x value is easy. 1, 2, 3, 4. The x value for the orange point is 1, 2, 3, 4. That's the easy part. What's the y value? Oh my goodness. What did we do? We went from here, from -1, we went up about radical 13, about 3.4. From -1, we went down radical 13. And that's the y value for our foci.